So in this example here from my notes, you can see that there is two samples involved. An internet service provider is developing a marketing plan. The internet service provider wants to know, is there a difference in the amount of time that males and females spend online each day? Now, we don't expect that the sample means are going to come out perfectly identical. That would be not usually the case. And in this example here, they have the males reporting an average time of 85 minutes online, and the females 81 minutes online. But we want to know, is that a statistically significant difference, taking into account all the information we have? And so when we're doing the hypothesis test, you may write your claim in a number of ways. You may write that you believe that the true population mean of the males is equal to the true population mean of the females. Male time, and this is female time. Now, it would be strange if those population means were identical. We don't really expect them to be identical, but they may be close enough that we could make that claim with some confidence. That could be your claim. Or you may want to instead claim that mu1 is not equal to mu2. These are the kind of claims that we'll make in this chapter. And we don't know which one is being claimed here until I read the question further. Okay, let's see what they said. They want to show, is it possible to determine with some degree of certainty whether such a difference exists? If they're talking about mu1 being equal to mu2, because it involves equals, that would be HO. But there would be an alternative claim to that as well, which is the opposite of it, and that is HA. And that would be that mu1 is not equal to mu2. Now, which one is the claim? The way that it's worded, to me, suggests that this is the claim actually being made, because they say try to show if there's a difference between them. So I would go with that. Either way, the test is gonna, follow the same mathematics. But yeah, that's that. Okay, so then we take a random sample from both groups. We want to subtract them and get a difference between the sample means, and we would use that in our hypothesis test. What's shown here is the sample mean came out having a difference of 4. They started off with the null being that there is no difference. And if that's the case, then we would be right here in the middle. That's where mu1 minus mu2 is assumed to be 0. But as you can see, their test statistic here came out quite a bit to the right of the mean. And that's what these tests are going to be about, is trying to show if that difference is significant or not. There are about 110,800 public elementary and secondary school teachers in Georgia and about 108,400 in Ohio. In a survey of 200 randomly selected public elementary and secondary school teachers, they were asked to report their salary. There's some sample means given here, and it says write a null and alternative hypothesis for this situation if it's claimed that the mean salary of Ohio is greater than the mean salary of Georgia. One way to say that would be that you believe the mean of Ohio is greater than the mean of Georgia. Now, this is the population means I make my hypothesis about. And then that's going to be the claim. It is going to be HA because it doesn't involve equals. And then we would do the opposite for HO. Okay, now we have to look carefully at the conditions for performing a z-test. What is required for this type of problem? We have to know the population standard deviations of both of the populations involved. It has to be that the samples are approximately randomly selected. Samples should be approximately independent. And the populations have to be normally distributed, or our sample size should be at least 30. In this case, we do have sample sizes that are at least 30, so we're all set on that. The states are totally different populations. But one problem here says, what additional information would we need to know in order to actually perform the z-test? You'd have to know sigma 1 and sigma 2. That was actually never given in the problem above. They gave means, but they didn't give, standard deviations. So that's the problem. It says here, a credit card watchdog group claims there is a difference in the mean credit card debts of households in California and Illinois. The results from a random survey of 250 households from each state are shown below. The two samples are independent. They give you a sigma 1 being $1,045 for California, and sigma 2 is $1,350 for Illinois. We want to write a null and alternative hypothesis, and then find the mean and standard error of the sampling distribution. The standard error formula is above. And see if you can just draw the rejection region. I'll let you try it here for a moment. We have to express somehow that there's a difference between population mean for California and population mean of Illinois. So one of the easiest ways to write that is to write that when it comes to mu1 and mu2, they are not equal. That's probably the most straightforward way to express that there's a difference between population means. And that could be considered the claim. That is what the watchdog group is claiming. Now, is that going to be HO or HA? This is HA. It's the alternative hypothesis because it involves not equal to. The opposite of that is equal to, and that would be the HO. Now, there is another way of writing that same thing that you may see often, and that would be to express the difference between population means like this as mu1 minus mu2. That's an algebraic way to express the difference, and then say that that difference is not 0, saying there's a significant difference. The opposite of that, though, would be that the difference is 0. So this could be an HO and an HA for this same problem written in a different way. All right, those are the methods that we want to get used to for this section. A lot of them are going to be like that. Now we have to find the mean and standard error of this sampling distribution. All right, so when we do a test for a difference between population means, we want to base our test on the null, which is this or this. So the difference between mu1 and mu2 is 0, so that's what we put in the middle of the curve. Now it says, find the standard error of the sampling distribution. So the standard error has formula above. All right, so Okay, that is the standard deviation of our sampling distribution for differences of the means. It's going to be square root sigma 1 squared over n1 plus sigma 2 squared over n2. And we just have to plug in. Sigma 1 was 1045. N1 is 250. Sigma 2 is 1350. And N2 is 250. I get 107.97, so about 108. All right. Now, just out of curiosity, what is the difference between the sample means here? We want to do x bar 1 minus x bar 2. That is 4,777 minus 4,866. I get negative 89. Alright, now, if we were going to do this test, where would the rejection region be drawn here? Is it a two-tailed, one-tailed test? Left-tailed test, right-tailed test? Because of the equals involved here, if you go above 0, too far above, you may reject. Or if you go too far below 0, you may reject as well. So this is going to be a two-tailed test. We'll have rejection regions on both sides of the 0. Now, I don't know if the negative 89 would fall in the rejection region or not. It might be that it lands up here, or maybe it lands up here. We don't know until we have more information about how big the rejection regions are going to be for this problem. Okay. Here's the steps for actually carrying out the entire test. And we will try it. So now they're giving us just a little bit more information on that same problem. They're telling us to use an alpha of 0.05. So go ahead, just for a little practice for yourself. Can you find the ZC that goes along with a 0.05 alpha level? Just a little bit of a review, nothing different about that part. We have an alpha level of 0.05 and two tails. I'll go to the formula sheets. Alright, here's two tails. Here's a level of 0.05. Let's trace that down. We will go all the way to the bottom because we're not using T, we're using Z at this point. So 1.96 is going to be our ZC for this test. Now what we need to do is we need to find the Z star, the test statistic for this data here. Alright, now the formula is Z star will be x bar 1 minus x bar 2 minus mu 1 minus mu 2. Our numerator consists of our sample difference minus the hypothesized population mean difference. And then we put that over the standard error that we had calculated earlier. So that's going to be sigma 1 squared over n1 plus sigma 2 squared over n2. So the x bar 1 minus x bar 2 can be easily calculated from the sample statistics here. I had calculated it earlier, actually. And now when it comes to the difference in population means, we have to go off the null and alternative. The null for this problem was that mu1 is equal to mu2, which another way to say that is mu1 minus mu2 is 0. That is the null. That's what you assume to be true for the purposes of doing the test. Therefore, mu1 minus mu2, you just plug in a 0 there. Next, let's plug in the standard error here. Alright, I'll see what I get. I'm getting negative 0.824. And if I just show the numbers that went into that, it would be negative 89 over 108. So the actual sample mean difference was $89, but the standard error was 108. If our standardized test statistic is negative 0.82, would we be in a rejection region or no? We would not be, right? We are somewhere around here with our z star. So what does this tell us statistically? It tells us we would fail to reject the null, which means just informally that we like the null. And then we don't like the alternative. And since we don't like the alternative, and the alternative is the claim, we don't like the claim. So I'll say at the alpha level of 0.05, there's not enough evidence to support the claim. The idea being that these salaries are close enough statistically together that we can't conclude with a lot of confidence that they're significantly different, because that was what it was all about. The watchdog group claimed that they were different. We showed statistically that they're not different enough to make that claim.